In this next section, we're going to start multiplying and factoring polynomials. So in problem number 1, we're asked to find out what is the polynomial that results from multiplying a negative x cubed through this quantity. So all we have to do is we distribute, which we've been doing before in the past. We're going to distribute this negative x cubed through to every single term within that quantity. So as I always like to do, I always like to start with my sign. So negative times a positive, I'm going to end up with a negative. Then I look at what is my coefficient. The coefficient on here is a 1. So I want to multiply 1 times 9, and that gives me 9. Then x cubed times x to the 4th. Go back and remember what your rule is. If you're multiplying like bases, then that means that you're going to add the exponents. So we've got x cubed times x to the 4th, which means we add the 3 and the 4, and we're going to get x to the 7th. The next thing we're going to do, we're going to move on and work with this term now. So negative times a negative is a positive. 1 times 2 is 2. And then x cubed times x cubed is x to the 6th. We finally have to go through and do the last term. So negative times a positive is a negative. 1 times 7 is 7. And then there's nothing to multiply this against. It's just an x to the 0th. So just multiply it by 1. X cubed times 1 gives you x cubed. So your solution is negative 9x to the 7th plus 2x to the 6th minus 7x cubed. And here we have a 7th degree trinomial. For problem number 2, we're going to revisit greatest common factors. Now, greatest common factors are just simply going to be division. What we're doing is we're trying to figure out what is the biggest number that goes into both this and this one here. So if I come over here to 12 and I list out all of my factors of 12, I get 1 and 12, 2 and 6, 3 and 4. If I come over here to 18, 1 and 18, 2 and 9, 3 and 6, and then that's going to be all that goes into 18. So I go down this list and I see a 12, but there's no 12, a 6, there's a 6 here, and so you can see that the greatest common factor between 12 and 18 is going to be 6. Well, if I'm doing that same idea over here with this problem, 5x cubed plus 25x squared plus 45x, I have to apply it to both the number and to the variable. So here's what I'm going to do. I'm going to start with the coefficients. So I've got a 5, a 25, and a 45. What number goes into 5, 25, and 45? That's 5. So what I'd get is 5 is going to be part of the greatest common factor. Then I ask myself, how many x's do I have on this term? There are 3 x's on that term. There are 2 x's on that term, and then there's 1 x on that term. So what's the greatest number of x's that I can take out of any single term? And that's going to be the 1, because I can only take 1 out of this one. I can't take 3 or 2 out of this one. So I'm going to take 1x out of that, so my greatest common factor for this problem is going to be 5x. In problem number 3, we're not just going to find the factor or the greatest common factor for this expression. We're actually going to factor it out or divide it out. So before I can do that, I've got to figure out what is the GCF for this. So I look at the coefficients. I've got a 4, a 24, and an 8. So what goes into 4, 24, and 8? You get a 4. So I'm going to take a 4 and write it down. Then I take a look at how many x's do I have in each term. I've got 5, 3, and 1. So what's the greatest number of x's that I can factor out? I can only factor out 1x because that's all I've got over here on this term. So I'm going to write down an x next to that 4. So my greatest common factor is going to be 4x. But now I want to factor it out or divide it out. So to do that, what I'm going to do is say, how many times does 4 go into 4? 1 time. So I'm only left with just a 1 there. I'm not even going to bother writing it because I don't need to write a 1. Then, if I divide x to the 5th by x, what do I have left? I have an x to the 4th left. Because remember that anytime that you divide a like base, you're going to be subtracting the exponents. So this is really x to the 5th minus 1. Then negative 24 divided by 4 is negative 6. X cubed divided by x is x squared. 8 divided by 4 is 2. and then x divided by x is 1. So then you get the solution 4x times the quantity x to the fourth minus 6x squared plus 2. To check yourself and see if you did this correctly, all you have to do is distribute the 4x back through to the quantity and see if you come out with the original problem. So 4x times x to the fourth is 4x to the fifth. 4x times negative 6x squared is negative 24x cubed. 4x times 2 is 8x. So we know that we did this correctly, and we know that this right here is going to be the solution when we're looking to factor out that 4x. For problem number 4, we have a word problem. And what we're given is this drawing that tells us that this is a helipad. So one of those pads that's located on the top of a building that allows helicopters to land on it. And we're being asked, what is the area of the shaded region? So these corners here, what is that area? Now we're told that this is a square and that the shape inside of it is a circle. So what we've got to do is we've got to figure out how are we going to find out what the area of that shaded region is. What this comes down to is the shaded region is basically going to be the square, the area of the square, minus the circle. So now that I've kind of figured out what am I looking for, I can start replacing these things with some formulas. So I'm going to call the shaded region A. And A is going to be equal to the area of the square. So what is the area of a square? It's going to be s squared. And then we're going to subtract the area of a circle. So we need to know what is the formula for the area of a circle, and that's going to be pi r squared. So now we know we've got, this is going to be our formula. So now we need to start substituting in some known variables or some known numbers for all of these, or for all of those pieces of information. Now if you go back to the drawing in the book, it tells you that the side of the square is 2x units long. So we can substitute 2x in for the side of the square. So we're going to go 2x, and then that's going to be squared. Then we're going to subtract the area of the circle. So we've got minus pi. The radius of this circle is x, so we're going to put in x, and then that gets squared. So now we just got to go through and start simplifying a little bit. So we get a equals 2 squared is 4, and then x squared is x squared, minus pi x squared. So you might think that we're done here, but we're actually not. We need to simplify this a little bit more. And what you can see is that we've got our coefficients are a 4 and a pi, and then our variables are an x squared and an x squared. So we can actually take the GCF from both of those terms and get a simpler answer. And so the answer is going to end up being a equals, we can take x squared out of both terms. And so we're left with then with 4 minus pi. So the solution is going to be the area of the shaded region is a equals x squared times 4 minus pi.